I greet you all, ladies and gentlemen. In this video, we will be focusing on organic chemistry, and it is targeted primarily to college students, particularly those that will be sitting for examinations, such as the SSCE. In this video, we will be introduced to organic chemistry, and subsequently, we will be treating important topics in organic chemistry, such as electronic configurations, hybridizations, Lewis theory, electronegativity, homologous theories, functional groups, and organic reactions. This is important because about 40% of these examinations are being consisted of organic chemistry questions. The practical aspect is already been taken care of by chemistry and possibilities. Continue subscribing to the channel, and on this channel as well is to continue enjoying the benefits. Please click on the subscribe button and click on the notification. This is to notify you any moments by which we drop new important videos. Thank you. I am Emeritus. Chemistry. When you hear organic chemistry, what comes to mind? What do you think about organic chemistry? Basically, organic chemistry is an aspect of chemistry that focuses on carbon. The focus of organic chemistry is on carbon. So we expect that any compound that contains carbon is organic. Now, is there any exceptions at all? Yes, there are exceptions, because there are some compounds that will contain carbon, and of course, they won't be organic. Well, when we say organic, it means compounds that come from living systems. So the exceptions include the carbon dioxide, carbon monoxides, carbonates, and the carbides. All these compounds, they contain carbon, carbon dioxide, carbon monoxide also contain carbon. All carbonates, sodium carbonate, calcium carbonate, and so on. They contain carbons, but they are not organic. So these are exemptions because they cannot be found in living systems. Now, your guess will be the same like myself, like why is carbon so much important? To the extent that a particular aspect of chemistry is not focused on it. Carbon important. Carbon can be seen as important because it is the what? It is the building block of life. All living systems contains carbon. Now we can see it from the process of photosynthesis, in which a carbon dioxide that is being produced naturally from the atmosphere, which contains carbon, is being consumed together with water in the presence of sunlight using the chlorophyll that is present in plants to manufacture their foods, which in the end generates their foods in form of sugars and oxygen. This oxygen is important for life to continue because this oxygen is actually being consumed by human beings. Now, without plants, which are being referred to as primary producers, life will not continue. All living systems contains carbon. Another reason why carbon is important is because of its abundance. Carbon is the fourth abundant element in the universe and the second most abundant in our body systems. The lipid, protein, carbohydrates, all of them contain carbon. Another reason is the position of carbon in the periodic table. Carbon is at the center of the periodic table. In this case, carbon will have a tendency to form bonds with various elements. Carbon actually is tetravalent. What this means is that carbon can form 4 bonds with other compounds. Another reason is because carbon can transport. What this means is that carbon has the ability to form long continuous chain with itself. So this is catenation. This can continue. That is why we have polymers, proteins that contains long chain carbons. So this ability of carbon makes it to be very much important. And of course, it's draw attention to itself. Now we move on to the classes of organic compounds. At this level, I'm going to classify organic compounds into 2. When we say organic chemistry, we study organic compounds. Now the first that I will mention is the aliphatic or acyclic organic compounds. These compounds, they contain straight or branch chain, but they don't contain rings. An example is this compound. Butane contains long continuous carbon. It can be branched. Now, aliphatic organic compounds are being also subdivided into 2 that have the saturated organic aliphatic organic compound, and we have the unsaturated. When we say the saturated contains only single bonds. The single bond will connect the carbons together. This is an example. Then the unsaturated can also be. We have those that contains double bonds. An example is butane that you are seeing on the screen. You can see at least one of the carbons contains double bonds. Then the other type of unsaturated one is the one that contains triple bond, which is butane here. At least one of the connecting carbons contains triple carbons. Now we can move rings. You can see this compound now, is not only branched, but there is a ring connecting the carbon at top, which is giving us like a square shape. This is cyclobutane. The one containing 3 carbons is cyclobutane, or you can just draw a triangle like this. This and this are the same. This can be drawn as a square. Then we also have what? Cyclohexane containing 6 carbons. It can be drawn like this. So it can also be saturated or unsaturated, depending on how many bonds is connecting the carbons together. All these ones are saturated because they contain just single bonds. We can introduce unsaturation in the sense that we can have a double bond anyway here. Of course, one of them, each of carbon that is connecting double bond in the sense of alkane, we lose one hydrogen. So that can be unsaturation here. We can change this one to cyclohexane by having 2 bonds at the carbons here. Now we can pick all these with this chart. Organic compound being divided into 2. We have the one that are aliphatic, that contains straight or branch, no ring, and we have the cyclic that contains rings. The aliphatic, I've mentioned that it can be saturated in the sense of ethane, single bond, and unsaturated in the sense of double bond and triple bond. In cyclic organic compounds, we can have those ones that doesn't contain aromaticity. When we say aromaticity, they are the one that contains benzene ring. This is a benzene. So in any aromatic compounds, majorly, we will see a benzene. This is a benzene. These are 2 benzene being fused together to form a naphthalene. Then we have methyl benzene. Then this is a methyl and that benzene. So making protein, this is also aromatic. So if it is not aromatic and it contains ring, then it can be saturated or unsaturated. Then another class under this are the heterocyclic compounds, which I am not going to talk about at this level. These are the cyclic compound that contains heteroatoms. Heteroatoms are atoms that contains high electronegativity, such as oxygen, sulfur, nitrogen, that has been fused into the ring. Examples here we have fluorine, iodine, pyridine. They are heterocyclic compounds. They are a large class of organic compounds, and they are very much important. Very important. Video will be on homologous series. In subsequent ones, we treat important topics, chemistry, the ones I have listed before the class. Now, please click on the subscribe button on this channel and click on the notification channel to be alerted when I drop next video. Thank you. And to chemistry teachers that will come across this video, please share to students that are writing the exam so that they will have excellent results. Thank you.